All right, what's up, guys? Back here with systems of equations, and here we're going to be looking at how we solve systems of equations by graphing, okay? And so I have an example here, and it says, find the solution to the system. And we have these two equations, right? We said systems of equations are kind of problems or sets of two or more equations, and we try to find a common solution to these. Okay, so on a graph, that's not actually going to be too hard for us, okay, because it's very easy to observe when looking at a graph where the solution is. Okay, so let me just graph these lines, right? Something we learned how to do before. Okay, so if we look at these, right, these thankfully are both in slope-intercept form, right, that y equals mx plus b. And so we're able to determine the m and b values, right, just by looking at these equations, right? We don't have to solve them for y or anything like that. Okay, so for this first equation on the top, it is y equals 2x minus 1, right? So my b value, where I begin, is -1 on my y-axis. And then my m value, or my slope, is 2, all right? I could think 2 over 1. And if I think of that as rise over run, or change in y over change in x, I think I move up 2 and right 1 from this point. Okay, so I would move up 2, right 1. That's where my next point is. Okay, and I keep that going. Up 2, right 1, point. Up to right 1 point, and keep that going. So there it is. There's my line. That top one, right, that I did in this nice maroon color. Okay? Okay, so there's my first line. I changed my second one just so I wouldn't get a decimal answer. I want to avoid that here while I'm first showing it to you guys. So if I do this one in the blue color, right, I start with my b value here, that +8. So I go up to +8 on the y-axis. That's where I begin. And then this slope, right, -x, right? So I think -1 over 1, right? So that means for my slope, or my m value, I move down 1, right 1. Okay, so down 1, right 1, point. Down 1, right 1, point. And I keep that going, down 1, right 1. You see, oh, it hits my first line. That's going to be important. But there is my second line there in blue. Okay, didn't do very well at drawing over all my points, but that's okay. So what do I look for here, right? With my goal of solving this system, right, finding the solution, where would it be? Well, as you could guess, right, the important point on here, kind of, that's a common solution for both lines, would be that point, yeah, where the lines intersect each other. Okay, so that would be right here. Okay, and so if I'm wondering, okay, what is the solution to this system? Again, we said this, all solutions to systems are ordered pairs, x comma y, right? So if I'm wondering, okay, what's the solution? I see, okay, that is the x value is 3 and the y value is 5. Okay, so that would be the solution to this. 3 comma 5 would be the answer, right? I need an x value and a y value for my answer, and I have that with this, okay? So we're just maybe going to do one or two more examples with graphing by hand, and then I'm also going to show you in Desmos how we can do it too. Okay, so let me erase this and we'll get up two more. Okay, so I've got my two new systems up here. Okay, directions are the same. Find the solution to the system. Okay, and so I'm just going to graph these, right? Graph these by hand. All right. So this first one, y equals 3x minus 7. Okay, so I'll graph that. I'd start that -7. So at -7, the b value down there, and then that slope of +3 over 1. So that means I move up 3 and right 1, make my new point there. And I keep that move pattern going so that when I finish up all my points here, it looks like that. And then this second line, though, this second line is going to be interesting, okay? Because it's just x equals 5. Okay, so what does that mean if I did that in pink, right? We talked about how x equals 5. If it says x equals a number, right, that means I go to x is 5 on the x-axis, and I would draw a vertical line, right? We said VUX, x equals equations are vertical lines, okay? So it's just a straight vertical line at x equals 5 there on the x-axis, okay? But we still would consider all of these points on, all of these would be points, right? Because they're kind of all touching a corner or a whole number of this, okay? So I didn't draw all my points on here, but yeah, technically they are. And that includes, right, because what we're looking for, the solution would be where they intersect, right? And so that would be right here, okay? So if I'm wondering what's the solution to this system, I look at that point right there and I think, okay, what are the coordinates of that point? And so I look, my x value is obviously 5 because it says that, and then the y value would be 8. So my solution to this system would be 5 comma 8. When x is 5, y is 8. Okay. And if I plugged in 5 into the first equation, I should get 8 as an answer. Okay. So that is true. Okay. Now, number 2. Number 2 is interesting. Okay. 2x minus y equals 10. Okay. And y equals negative a third x plus 4. Okay. Now, one of these equations is ready to be graphed by hand, right? This one, because it's in slope-intercept form. Okay. But we also learned that when a line, or when an equation, excuse me, does not have y equals whatever, and I'm asked to graph it, it's harder for me to do that, right? Because I don't know what the slope and the y-intercept are just by looking at it, right? So we talked about how you can take this equation and actually solve it for the letter y, right, to get y by itself so that it's in the y equals mx plus b form, okay? So if to do that, I would minus the x term here, right, from both sides of the equation. So minus 2x, minus 2x. But remember, we said this 10 minus 2x, those two can't combine, right, because they're two different types of numbers. So instead, I would just be left with this negative 1y equals, and I would leave those separate. It would just say, it would stay 10 minus 2x, okay? And now I need to divide this coefficient with the y, divide by that negative 1, okay? I do that, and that cancels, so I'm left with y equals, and I divide these individually, right? So 10, positive 10 divided by negative 1 would be negative 10, okay? And then this negative 2x divided by negative 1 would be positive 2x. Or for my slope, right, I could say 2 over 1x, okay? Because that negative divided by a negative changes it to that positive, okay? And so now, this is really my first equation, right? I just rewrote it so that I can graph it. And then the second one stays the same, okay? So let me graph this first one, right? And it's kind of flip-flopped, right? The mx and the b values are kind of flipped, but that's okay, right? So my b value here would be this negative 10, okay? So that's all the way down here on my y-axis. And then that 2 over 1, right? 2 over 1 is my slope. So I move up to right 1 and make my point. Okay, so I keep doing that over and over. And it's important that you do it. You do it as much as you can because sometimes the intersection point is really far away. So if you just kind of like stopped right there, you might not get exactly where the intersection point is. So it is helpful to if you're asked to do it by hand, just graph it, continue that move pattern as many times as you can fit it. So there we go. Okay, so there's my first equation that I rewrote. Okay, now my second equation I can keep the same, right? Because it already says y equals whatever, right? So plus 4 is my b value, so I go there to positive 4. And then my m value, my move pattern says negative 1/3, right? So I move down 1 and right 3. So down 1, right 3, down 1, right 3, point. Okay? And I already found my intersection point, so there's no use in keeping this line going because I already found it. Okay? And so there we go. And now I just look and see, okay, what are the coordinates of that point right there? And for that one, the x value would be 6 and the y value would be 2. So 6 comma 2 is the solution to that problem. Okay? And I'm done. All right, so hopefully that makes sense. That's kind of graphing a system by hand, right, and just looking for that intersection point. I'm going to show you here how you can do it in Desmos too, and that actually makes your life very easy, okay, like Desmos often does. So I'm going to switch over to Desmos, and then that'll be about it, all right?
All right, guys, we're here, and I'm going to just show you one or two examples of graphing these systems, right? We just saw a bunch of them, graphing them by hand, and right, we're seeing that it's the answers where the two lines intersect each other, right? But if I did it in Desmos, okay, watch this. Y equals 2x minus 3. Okay, so again, you guys know Desmos will graph that for you. Okay, you can see the line right there. And then if I graph that second equation that's giving y equals x minus 1, okay, again, it graphs it there. And if I was to, again, click, right, Desmos is so nice because it highlights the point, right? It highlights the x and y intercepts here. Okay, but let me zoom in a few times. Okay. It also highlights for you that its exact intersection point, right? When you graph two lines, it tells you where they intersect. Okay. So this point 2 comma 1 is where they intersect each other. Okay. So I'll give my answer as 2 comma 1, meaning the x value is 2, the y value is 1. That's where they meet each other. Okay. So how nice is that? Desmos does it for you. Okay. Okay, now let me just show you this next one, and this one's going to be different, okay? So if I graph these, okay, again, look at these two equations. These two normally would be really hard for me to graph by hand, right? Because they're not in this slope-intercept form, right? The y equals this, y equals that. Okay, notice it doesn't say that. The y is not by itself. So I would have to take these and solve them for y like we learned in Unit 2 to be able to solve these, okay? And that would be tricky. But that's no problem for Desmos, okay? Because look, 3x minus 2y equals 10. I just type it in exactly how it is, okay, how it looks without solving it for y. And look, that is completely solved. That's completely graphed, right? Totally normal line. Okay, so that's awesome. That's what's really nice with Desmos. You don't have to solve the equations to make them look a certain way. And then the second one, 5x plus 2y equals 14. Same idea, right? These are graphed. And again, so we'll be looking and seeing, okay, where do these two lines intersect each other? And we see right there, 3 comma 0.5. So again, looking back at my, right, this is technically a multiple choice question, so sketch what you see on Desmos. Yeah, we won't do that. But yeah, so if I was choosing my answer, positive 3 is the x, right, and all of these have that, comma negative 0.5, negative 1/2, right, that would be. So that would be, that's a terrible circle, but yeah, that would be answer B here, right, 3 comma negative 1/2. Now let me show you these two special cases real quick, okay, just to kind of wrap this up. So some special cases. So if I type in that first one, I know that's small, but y equals 2/5 x minus 4, okay, and then y equals 2/5 x plus 2. Okay, look at these two lines. Okay, what would we call these? We would call these parallel lines, right? Because these two lines are going the exact same direction, right? And we know that that's because their slope is the same, right? So two lines with the same slope are parallel. Yeah, so that's what happens with parallel lines. Are they ever going to intersect each other? No, right? You could zoom out and zoom out, right? And I know it looks like they're going to get closer together, but yeah, these lines will never intersect each other, ever, okay? So in that case, if we were given this question, we see the lines are parallel, we would put no solution. No solution, right? Because if a solution is where the lines intersect, and these lines never intersect each other, yeah, there would be no solution to this. Okay, now watch this. This one's going to be a little bit weird, okay? So I'm going to type in these equations. So 4x minus 2y equals 12. Okay, so there's that first equation, that black line. Okay, this next one, 8x minus 4y equals 24. Did you see what happened there? The lines, when I make it 24, the lines are right on top of each other, right? So these technically are the same exact line, okay, which is cool. So these, and again, that's not just that I'm like so zoomed out that they look like they're close together, right? No matter how many times I zoom in, yeah, no matter how many times I zoom in, these lines are going to be the exact same, okay? So they're the same line, okay? So in that case, the solution to this system is all real numbers, okay? Because if we're wondering when do these lines intersect each other, they're always intersecting because they're the same line, okay? So because these lines are always intersecting. Okay, so that is all. That is all with graphing systems in Desmos. Okay, so hopefully that makes sense and seems some special cases here. Yeah, so that's all. Thanks for following. Bye-bye.